Hi, this is Kyle. Hey, for my last video, I got a lot of requests to give some more build information on my taper pattern turning jig. Say that 3 times fast. Anyway, the one I highlighted in the video is this one, in the previous video is this one here. And this is the one where I use this fixture plate to basically lock this in and with this cleat here, provide a little bit of adjustability there, along with this being screwed into this fixture plate. So I got a little bit of adjustability here. And what I mean by adjustability is when you're building these jigs, you're trying to get this perfect taper. So this is for a 6-degree taper. So I basically cut with a miter gauge on the table saw this 3-degree taper right here, and that's what the tool holder, as I'm calling it now, rides against. And that creates the 6-degree included angle taper. So it's 3 degrees here, 3 degrees on each side of the taper. That's 6 degrees total. Now this tapered pattern is glued to what I'm going to call the plate, so we don't get our terms confused. So this here is all glued together, so it's all one part. And what this allows me to do is, since it's screwed to this fixture plate, is I can loosen these screws and move it just a little bit. These holes here are a little bit oversized, so I got a little bit of wiggle room there. And the reason you need this is no matter how well you build this and how straight everything is, you're gonna have to dial in this taper. I mean, I'm basically cutting this on the miter gauge at 3 degrees. I got an Incra miter gauge. It's really accurate, but even so, you want a little bit of room. So with this one, I actually probably have too much adjustment, because I got adjustment on moving this back and forth, and I got a little adjustment here moving this back and forth. It works well. It works absolutely fantastic, but I don't think you need all that adjustment. Now, one thing you can see here is these are witness marks, and once I get everything lined out and everything dialed in, so to speak, then I go ahead and put a little piece of blue tape and make a mark here and make the cut where these two meet, because that's where it adjusts since this is glued together. And so that gives me a visual indication when I go to use this jig that, hey, nothing has moved. And the same thing over here is I got a witness mark on both sides of that. So let me give you some build details. Now I'm going to break this up into a couple of different videos. This video here is just going to be about how I build what I'm calling the plate and this tool holder, along with this pattern template. So I'm going to go into that, and then I'm going to have another video where I actually go and show you how to dial everything in and set everything up. So what I did after I made that one is for my stretcher drilling guide, I make basically I make a bunch of different versions, or I have made a bunch of different versions, but the two most popular are for 6-degree tapered tenons and 12.8-degree tapered tenons. The 12.8 degree is what the Lee Valley reamer is based on. So this is the one I made for that. And I think this one is going to be applicable to most people out there that actually want to build this. You don't have to buy that aluminum plate. When I bought that aluminum plate, it was like 40 bucks. Now it's like 80 bucks. So don't recommend this. This is going to work for most people and in most cases. And if you want any other information on the aluminum plate, where I bought it or things like that, just leave a comment or hit me up on Instagram, and I'll be happy to provide you with the details on where I purchased that. It was just off eBay. But so this here is my, like I said, my 12.8 degree taper one that I rebuilt. Now, originally when I threw these together, and I really threw these together, as I used whatever was around, and I built these with 1/2-inch plywood. I should have gone with 3/4 inch, something much sturdy. And I think if you're building these, go with 3/4 inch. But what I did is just took my old 1/2-inch one and glued, took the finish off and then glued a 3/4 inch piece of plywood. So I'm going to talk about the plate first, and we can go through that and kind of go through the build order here. And here's the way I would build it. First thing I'm going to build is what I'm calling the plate. Subtract this pattern. We'll build that later. That has gone on here, but we can go over the dimensions now. This, let me just to give you a little preview of what's coming up, is this pattern here, the tapered pattern, is basically screwed on to the plate. I have some threaded inserts in here that this then goes through and goes into, and the holes here are a little bit wider, so that gives me some adjustability here. The other thing we have is this clamping block. You can get this from One Way. They sell them, and I think you can find most of them on Amazon, matter of fact, if you search for them. It's a clamping block, and basically this fits between the ways. So these cost about 20 bucks. I'll have links and more information in the description about how everything's built. So let's go over the dimensions. So like I said, this is the one I did previously. So we're just talking about the plate here. So it is almost 12.5 inches long, and then it's 8 inches wide. And that works great for my lathe. Like I said, the ways on mine are 1.25 inches in between, and this gives me enough. But if you have a bigger lathe, like the width of my lathe at the ways is 6 3/4 inches, and the distance, the gap in the middle, that gap between the ways, is, like I said, 1.25 inches. So that would work fine. If your lathe is similar to mine. If yours is bigger than mine, then I think this, from the center point to the end out here, you can make that a little longer. So that's going to, be up to you and the dimensions of your lathe. But from the center mark where I have the cleat is exactly 9.5 inches from this end to the center line. If your lathe's bigger than mine or shorter than mine, that distance should be right at the same. Your cleat's going to be wider if your lathe is bigger and whatnot. Now the cleat, like I said, mine's 1.25 inches, and it is 4.5 inches long, and that works really well. You can make it a little longer if you want, but that works relatively fine. And then this hole here, that's a 5/8 inch hole for that clamping block, and that's drilled right in the center too. So what I would do is, when I'm doing this, is cut out my my piece of plywood, the dimensions all straight, then use a square to strike a line at this 9.5 inch mark here, and then make your piece of plywood or whatever you want to use for your cleat, and make sure it fits snugly, but not too snugly between your ways. You can always make some adjustments if you need to by putting a little piece of blue tape or whatever to make that snug if it's a little bit loose once you get in there, because sometimes your ways are not exactly parallel. They'll vary by a few thousandths. So sometimes, depending on where your final placement of the jig on the lathe, when you actually do your pattern turning, you may need to make some adjustments with some blue tape or something of that nature. So the way I glue this on is these screw holes are for the screw holes that you see here. Those are for the old version, the prototype, let's call it, of the jig. So ignore those, but I never use these two screw holes to hold this cleat on here. Those actually help hold the pattern onto the top. But how I did this is I basically used hide glue, so you got a long open time. I have this line here. I erased most of it, but you can still see a little bit that's on the bottom of the plate. And then I also put some lines here here on the little cleat here that's halfway in between, so I could line those up and make sure that that is square. And then of course you always want to take a good square and then double check it here. Now if you wanted to go ahead and drill some through holes and then screw this on here with, say, maybe some Craig type screws where you could have some adjustability and clamp everything down, that's probably a good way to go too. Once you have that done, then you have this line here. Go ahead and drill for your clamping block, and like I said, that's a 5/8" hole. And with that, once that's all dried, you're pretty much done with the plate here. So the next thing you want to build is go ahead and work on your tower. So let's talk a little bit about, I'm sorry, I called it the tower. I should call it the tool holder. My prototype was tall, so it was a tower. But by the time I built all this stuff up, it's kind of short. It's not really a tower, it's more of a tool holder. So if I refer to this as a tower, just go along with it. So what can I say? All right, let's start here and talk about the tool holder. So we'll talk about this bar and the carbide cutter. Now I'm using a carbide cutter from Easy Wood Tools, and this is the round one. I prefer the round one because you can use one of the square ones as long as it's got a radius on it, but I would not use something that's totally squared off. It's just gonna make it extremely difficult to set up, because trying to keep everything square in line with this, it's just a mess. When it's round, it doesn't really matter. It's gonna touch the wood at one point and one point only. But this is, like I said, an Easy Wood round finish cutter, and it's a negative rake one. I found that works best. The other one works fine, just a standard round one works fine. But I found, especially for hardwoods, the negative rake one does leave a little bit cleaner cut. Now, this is mounted to this bar here. Now, this bar is some key stock that I had from when I made my previous one. This is part of the clamping mechanism. And I had some of that left over, so that's what I used for this. So this bar is 3/8 inches wide by 1/4 inch thick. And all I basically did was drill and tap for the screw to hold the cutter in here. Now this is the smaller cutter. Based on what I do and based on some of my tooling, I really need this to be as small as possible. If you had the larger one, that's fine. That would probably work equally well if you're just tapering legs and things of that nature. But I did use the smaller of the two that they sell. So I drilled and tapped that, and that screw is a 440. I'm not sure if that is the same for the larger one or not, but for the smaller one, it's 440. And when I mean smaller one, these are the ones that go with the Easy Start tool. So basically what I have here is, on top of my little tool holder, I have this block of wood. This is just basically one of my riser blocks for my spindle drilling guide. This one didn't quite make it, and I went, hey, this would be perfect to go ahead and use this. So I basically drilled out the bar here 1 inch on center to match the 2 holes that were already in this piece. And these are 5mm holes. Then in this block, I drilled in these 4 holes, these holes for these 4 screws here. And these screws just go into these holes here. And you will find that these aluminum extrusions, and I'll go over the details on this. This is 2 inch by 2 inch aluminum extrusion. These holes are drilled, and all you need to do is get a 1/4 inch by 20 tap and just go right through them. They're already at a perfect size to go ahead and tap these out. So that's what I did there. Now, the holes in the bar are 5mm. They go all the way through here, and then I have some nylon lock nuts on the bottom holding this to the wooden block. And then the wooden block just goes into here, and I have lock washers and regular washers in here just to keep everything tight. Now, here is the 2 inch by 2 inch extrusion. Then we have this 2 inch Gusseted bracket, get the gusseted bracket. It's very, very strong. And so you got 1, 2, 3, 4, so 8 screws and T-nuts locking this in place, 4 on each extrusion. Now this bottom extrusion here is 2 inches wide by 1 inch, and that helps lock everything down here. Now on the front, I have this plate here, and this plate goes into this bottom aluminum extrusion. Same thing as for the top, is it's got these 2 holes here, and I just tap those for 1/4 inch by 20, and then went in and then put these screws in, and then these are 1/4 inch by 20 into the T-nuts, and they lock into the upper part of this. Now, when I was building this, I went through all this stuff with the wood block before. I had a different mechanism I was going to do up here. I think I mentioned this in the previous video. If I was building this again, I would probably just buy 2 of these plates, one here and one to put up here, and I would just probably drill and tap this with M5 threads, and then sink this down, and then probably go ahead and still use some nylon locking nuts on the bottom just to keep everything square. So the other thing you might see is this black stripping here. This is just some plastic stripping. It's very inexpensive. You can get a length for like 72 inches for very cheap, just a few dollars. You just kind of cut it. I just actually use some heavy duty scissors to cut this stuff, and you can just stick it in there, and it goes into the T-slots here and keeps dust out of it, so you don't have to worry about it and dust getting in there. It's up to you whether you want to do it. You'll be blowing this and vacuuming it out when you're using it anyway, just to remove debris and brushing it out. But I think it helps, so I would kind of recommend it. So now all of this is attached to this base, this plywood base. Okay, and let me before we move that, let me get the dimensions of this. Like I said, this is 2 inch by 1 inch, and it is 7.5 inches long, and that's probably going to be just about perfect. It's to make this 7.5 inches long, and you can order that directly already pre-cut from 80/20. That's where I got all of this stuff too. The one thing you don't want to order pre-cut is this 2 inch by 2 inch, because I'm going to go over in a minute how you determined the length of this so that everything matches up, because you need to get this cutter, the very tip of it, right in the middle of your turning, or exactly centered on your lathe. So we'll go over on how to determine what the height of that is. Okay, so let's go ahead and go over the dimensions of the base here. So the base is 8.5 inches long, and it is 3 7/16 wide. You can make that 3.5. Now what I did is when I originally built this, it was a bit wider, and I experimented with sizes till I got something that's going to cut and still be able to reference off this far end right here. And the reason for the reference is we have an adjustment screw right here. So before we get to that, let me talk about how we mount this. So basically we have T-nuts that go into the slots on the bottom, okay? These slots right here, and that helps secure the base, and we got 4 of them, 1, 2, 3, 4. Now this also gives you some adjustment, because you can loosen those T-nuts and move this whole thing forward or backwards, and that's a key point once we get all this built, and adjusting this all in and dialing the whole jig in, both the plate and the tool holder. So these are 1 inch on center, and then I have these spaced out. And here's where I would make a change from the way I have it. I have these 1 inch from this end. I would actually make that 1.5 inches. That gives you just a little bit more room to move this back. So I'd make that 1.5 inches instead of at 1 inch. And then these bottom 2 screws are inches. Like I said, all I did is I drew a straight line down here and then measured off half an inch this way, half an inch that way, half an inch this way, half an inch that way, and that gave me these 1 inch on center, which will match up perfectly with these T-slots. All right, let's go over this adjustment screw here. What this is just a nylon screw. So this nylon screw just goes in here. It's threaded 1/4 inch by 20. I love 1/4 inch by 20, so you're gonna see a lot of that. So basically what I did was drill a 1/4 inch hole all the way down here. Then I drilled a countersink for the head of this, which is this 1/2 inch in diameter. So I drilled it just a little bit bigger than 1/2 inch. Actually, I have a lot of metric in my shop, and that is 13 millimeter hole to be precise. But anything just a tad over 1/2 inch is going to be fine. And then I put a threaded insert in there, and I think I had to countersink that in there by about 3/8. And what this allows me to do is when I'm actually using the jig, it allows me to sneak up on the cut and make reliable passes each time. So I can basically make a pass making that tapered tenon and then screw this in 1/2 a turn and make another pass. So it keeps everything consistent and makes everything nice and neat, and it's real easy to sneak up on your final diameter of your tapered tenon. Okay, it's been a couple of days since I shot the first draft of the video, and I did update a couple of things to this rig, to the tool holder. So I did put some different T-slot covers on these horizontal sections, and these kind of have a little bit of overlap. They kind of, compared to these here that fit inside the T-slot, these kind of overlap a little bit, and they were really good for these horizontal ones. They weren't so good for the vertical ones because there was a little bit of a gap here that dust and some really small shavings might get into. The other thing I did is I did put a cap on the back end of this, and these are just 1/4 inch by 20 screws, the same ones that are used here. And again, I just tapped the little holes in the extrusion, and those fit right in there and keep everything secure. Okay, the other thing I wanted to talk about is the actual tool overhang. So the overhang from the end of this wooden thing. You want to make that is, I guess, as small as possible, so you don't get any excessive chatter having this way out here. I have this just a little bit over 3/8 of an inch. The other thing I wanted to mention is the finish. As you can see, all these plywood parts are finished. I recommend you do that. They just have 4 coats of some rattle can lacquer, def lacquer on there. And then once that's cured, I like to give it a couple of days to fully cure. And then I just wax, especially this part right here where the tool holder is going to be sliding on. So I wax this, I wax the bottom of the tool holder, I wax this edge. So I think what we need to do now is move over to the lathe so I can talk about how you set the height of this, and also talk about what we're going to do with the pattern here. Okay, we're now over here on the lathe, and I have my plate mounted into the lathe. Well, it's not mounted, but I just have it placed in there with this. And you can see now, if your lathe is a little bit wider, what I was talking about earlier with building the plate, you might want to extend this this out. But this distance from the center line to here is perfectly fine, even if your lathe is a little wider. It'll be absolutely perfect. So now I wanted to go over setting the height of the tool holder. So it's for this piece right here, the 2 by 2 inch aluminum extrusion. So the way you do this is make the base, mount everything up just like here, except now you're going to have this, It doesn't have to necessarily be this tall, but this stuff's pretty inexpensive. So order more than you need in case you mess up and you need to cut it again. That way you only pay shipping once. So go ahead and mount this in here. So it would be like here. And you know, you'd have everything mounted and secure in. Now what you want to do is find out the dimension, the thickness from, in my case, this wooden plate plus this bar here plus the height of the actual cutter. And since this is a negative rake, the actual cutting edge is about 1/32 down from the top of this. Now, I got extremely lucky, and believe it or not, this block plus this plus the cutter equals exactly 1 inch thick. Yours will differ. So if I use this plate, it would not be 1 inch. It'd be a lot thinner. But, you know, what I would recommend doing is find some scrap wood, get it down to that dimension, because here's what we're going to do. So in this case, let's pretend I have this mounted up like this, and I want to set the height of this. So since I know right here that this is all 1 inch, then what I can do is simply, in this case, I'm going to take a 1, 2, 3 block that is 1 inch thick. I'm going to place it down here. Then I can place this here, like so. And, oops, I need to move this down some. Sorry about that. Now, where were we? Yeah, that should work. So, there our tool holder. We got our piece of 2 inch, and then what I can do is, this is hardened steel, is I can sit there and just put a mark right there on this piece, and so I know that it has to be exactly that length. Now, cutting this. If you've never cut aluminum before, your carbide tools will work fine. I just use my chop saw to chop it off right at that mark. Now, if you have to make any adjustments, if you make it too high, that's easy. You just need to trim some out. You can actually take this to a disc sander or something like that and be able to make real fine adjustments with aluminum. It's a bit messy, but it's not too bad. But if you got this too short, just barely too short, you can put like a shim underneath here. It's not going to affect anything, and you could just shim this up a little bit. Your T-nuts are still going to register and all of that stuff. So you could just barely shim this up a little bit. So that's how you set the height of this. Now let's talk about one of the most important parts, and that is your template pattern here. So like I said, this is on this particular one, this is for the Lee Valley reamer. So it's 12.8 degrees. So this angle here that I cut on my trusty miter gauge is at 6.4 degrees. That's right, 6.4 degrees. So did I nail it? I'm not sure. I think I came pretty darn close. But what I have is I have this built-in adjustment, as we kind of talked about at the top of this. So these 3 bolts go all the way through and into threaded inserts, so that I can then loosen these from the top. It's very nice to be able to do this all from the top. And if I need to make any adjustments to dial that taper in, I can move this whole thing this way or this way to dial that in and then lock it back down. And when you are making adjustments, be aware that if you have this mounted in here, you're going to have it mounted with that clamp block. So you need to loosen that up too, because that will also clamp these 2 pieces together. So you got to loosen that up just a little bit, then loosen these, make your adjustments, tighten these down, and everything stays in place, and all the adjustments are on the top. Now, how did I get all that done? Well, the first thing to do is I made this. Okay, now I want to talk about cutting this angle here on the template pattern right here. So how do you cut that angle on the table saw? Well, I found 2 ways. So The first one and the most direct one, this is a pattern I have from the prototype, and I have exaggerated the angle here. It's at 10 degrees. This pattern here was cut at 3 degrees. So it is exaggerated, but you can see the length of this is still, or the width of this is still 8 inches. So you can actually get that right here and kind of do it cowboy style. I would move this up to, you know, secure it here, and then I also put a clamp here, and then I'm able to go ahead and go through the table saw and cut that angle all in one go. Now, if that seems a little dicey to you, and especially if you have something that's more narrow here, what you can do is cut each side of these at 3 degrees. So you can cut one side, then mark it at 8 inches where that cut should be, and then what you would want to do is flip it. So, okay, let's just pretend that this little piece of MDF was what we wanted to cut. So if this seemed a little bit dicey, which it would to me, what you can do is instead of cutting this angle right here, instead of cutting that angle, what you can do is cut these two edges at 3 degrees. So you're basically creating a parallelogram. So basically you would cut this at 3 degrees like that, then flip that over, mark 8 inches from this side, so that would be your width, and then cut it this way. So basically you made this into a parallelogram, and you can then use that. Now you would have to, if you wanted to, you didn't have to, but if you wanted to create the back edge, you know, square, so it's square right here, you know, at the end here, then you could, you know, use a miter gauge, or you could use a sled or something like that, table saw sled, to cut that at 90 degrees. Now, once you've cut all this, what you then want to do is go ahead and cut a little rabbet here. It's a dust relief. So if you look at it here mounted, so you got the template here, and then I got a small little rabbet right there. And that basically just allows dust and small shavings, which you're gonna have small shavings when doing this, to go in here so it doesn't impede the tool holder as it goes up and down along here. I think it's a little over an 1/8 inch in thickness here, and probably about a little over an 1/8 inch deep. So that seems to work great. You might want to know, where do you place this off the center line? Here's what I did, and I think this will work for most folks, is there's a center line here. This is the center line of your way, so it's right here. It's the center line of your lathe, right to there, and that's there. I just extended this up, and then I took this edge and I made it 3/8 of an inch from the center line of the lathe. So the small end here, this is the large end, the small end here, this corner is 3/8 of an inch this way from the center line. So I hope that makes sense. And then what I did is I got this all squared up where I'm flush here and I'm flush over here, and I used double stick tape to tape this on here. And then I drilled these 3 holes. You could have these straight across in the middle, that would work fine too. But on mine, since I was actually dealing with some previous holes, I kind of staggered these a little bit. So anyway, so once I had those, I took this over to the drill press and drilled them. Now I drilled them from the bottom. I just put a scrap piece of plywood right here to keep everything, you know, even, and then drilled these holes. And so I drilled a 1/4 inch hole all the way through, came back and then counterbored these 3/8 of an inch for the threaded insert. I also, now remember, we had previously drilled this. Then I just mounted, I used a Forstner bit to drill this, a 5/8 inch Forstner bit. I just mounted that Forstner bit back in the drill press and got it in there, and then drilled through this piece here. In 5/8, even if you make adjustments, you're gonna have plenty of wiggle room. Now, to get that wiggle room, like what I said, as I drilled all the way through here, so these are 1/4 inch holes, I needed to make these a little bit wider so that I do have that wiggle room, a little bit more than the 1/4 inch hole would allow. So you could drill those at 5/16 or something like that. That would be fine. I actually drilled these out at 7 millimeters because I got a lot of metric stuff in my shop. So I chose 7 millimeters, but 5/16 would work fine. And then when we mount this is mounted again with the washer, lock washer, and a 1/4 inch by 20 bolt here. Now, one thing you will have to do, I don't know if you can see it on the video here, but you will have to cut bolts more than likely. So, you can figure this out and see what it is. Go to your local big box store and see if they have a length that will match perfectly. So you don't have to cut them, but if you do, then order something that's a little bit longer and then cut it to the correct length. I used an angle grinder to do that. I actually used let me show you. Okay, so I actually used this block of wood, and this is where I was doing some test cuts for an earlier version of this block. And this has a 1/4 inch by 20 threaded insert. So I can mark what length I want and then screw this down through here, clamp this down, take an angle grinder and cut it. I found that to be pretty easy. I do cut a lot of screws and bolts around here, so that's why I have things like this. But once you cut it, you want to go ahead and make sure you chamfer the ends here. And I just used, you can use like a belt sander. I used one of the rigid oscillating belt sanders. And you just want to make sure that you point this away from the direction of travel. So if the belt's going this way, then you want to do this way and just kind of turn it. And you can put a little chamfer on there really nicely. And then, like I said, run it through a nut a few times just to make sure that it goes easily through there. I think that's going to do it for this particular video. This completes the build process. And like I said at the top, I will have links to all of these components and some dimensions that I mentioned also. And I'll have another video out shortly. If you're watching this in the future, then it's probably already sitting there with how to dial all of this in. So once you have this constructed, now we need to dial it in so that you can make those tapers. Thanks for watching, and look forward to seeing you on the next video.